before time began, there was DNA. We know not where it comes from, only that it holds the power to create worlds and fill them with life. That is how our race was born.
"4 billion years ago, Earth was a desolate and barren landscape. Molecules would have been created by a random interaction between atoms. Interaction between these molecules would then lead to the formation of more complex structures. The more stable the structure, the more likely it would interact with another. In time, a molecule with the ability to self-replicate arose. This molecule would have had a new kind of stability: abundance. These elaborate molecular machines developed progressively advanced mechanisms of self-sustenance. Some would interact with one another. These machines, which we now call life, interact in such complex ways as to mask their original intention of continuation. Altruism is the concept of a single organism helping another at a cost to itself. Can organisms that have been selected for based on their ability of self-replication and self-replication alone exhibit altruistic behavior? The cellular slime mold Dictyostelium spends most of its lifetime as a single amoeba cell. But as its local resources become exhausted, it will emit a chemical signal that diffuses towards its relatives. This signal will cause other amoebae to migrate towards it and aggregate to then form a slug that is able to form a fruiting body. From the stalk, spores will be released to colonize a new region. The cells forming the stalk will die in order for their neighbors to be able to reproduce in this manner. This behavior may seem altruistic. However, it is simply the result of complex chemical reactions happening within the amoeba, of which it has no control. Claiming this behavior to be altruistic would be on par with claiming wood is altruistic, as it burns to keep you warm. Bees. These docile insects have evolved a rather non-intuitive mechanism of interaction. When in danger, worker bees will sting any organism they perceive to be a threat. As a result, the worker bee will die. Bees have been selected for through their ability of self-replication. How could such a suicidal mechanism arise? At a superficial level, this may be perceived to be altruism. However, this behavior is more easily understood when you consider that the worker bees are sterile. They cannot produce offspring. The only way they can help sustain their genes is to protect their fertile relatives. Acacia trees of the tropical savanna not only have thorns protecting them from hungry herbivores, but have developed mutualist strategies to protect one another from being eaten. When being grazed upon, an acacia tree will produce tannin, a bitter compound that effectively makes proteins stick together, thus disrupting the digestion of the animal eating it. To protect its neighbours, the acacia tree releases tannin molecules into the air, which are picked up by specialised receptors of trees downwind of the first. This communication is called hormonal sentience, and it triggers a pathway that induces the remaining trees to produce tannin themselves, effectively defending themselves against the coming herbivores. This may seem like altruism, but the trees have evolved this mechanism not to help others, but to indirectly help themselves. If the neighbouring trees survive, then, sometime in the future, the emitting tree will be on the receiving end and therefore ward off its predators. We have discussed seemingly altruistic behavior in various organisms, but does this logic apply to the most complex organisms on the planet?
Imagine two identical universes, identical from the most complex to the most simple level. As time progresses, any change in one universe will simultaneously happen in the other. It follows that the path each universe takes is based solely on its original conditions. The fate of the universe was determined the instant it was created, just as the amoeba is at the mercy of physics, as are we.